Ik ben heel blij dat we vanavond een spreker hebben en niet zomaar iemand, Mikhael. Ik denk dat we allemaal kennen, voor tenminste degene die we vorige keer hebben horen spreken. Toen ging het over La Palma en vanavond gaat het over Chili. Dus zeer interessant. Ik ga daar zelf niet veel over vertellen. I'm not going to tell anything about Chile. I think Michael, welcome. Also, welcome to Maria and Alexandra. We are all looking forward to hearing your travel stories from Chile and how the stars look there and what you actually did in Chile. All right? Thank you.
Okay. Goedenavond allemaal, ik ben Michael of Mikhael. Today I will speak in English. My Netherlands is not great, and it's a pleasure for me to be here again. I was here by invitation of Joost 2 years ago. And last time I talked about my trip to La Palma in Canary Islands. And today I will be talking about my trip this year to Chile. Maybe I'll start with one slide to introduce myself. Not all people remember maybe me. I was fond of astronomy from my childhood, as you can see here. It was started with the first astronomy book, my first telescope when I was at school. I also got a high education in astronomy in university. Originally I'm from Moscow. This is where I studied and got my high education. And then I started my professional career in the industry, not related to astronomy. And astronomy was a hobby, as you see. So, and I sometimes travel with the telescope to observe, and I'm a visual observer, mainly. So I don't take photos. I mainly enjoy the sky with the Dobsonia. Professionally, I'm working in IT most of the time, related to the IT projects, digitalization projects, and that's in short about me. So today I would like to make it interactive, so if you have questions, just stop and ask questions. If I speak too fast, stop me. If I speak too slow, also let me know. And also, if the subject is too boring, that let me know. I will try to make it as fast as possible, because today I prepared so many slides, and yeah, maybe you will know way more than you would wish to know, but okay, we will adjust the pace. So, Chile. Well, Chile is a very remote place, as you know, and my flight was 14 hours. So it was the longest ever flight I took. It was flight from Paris to Santiago, 14 hours. It's I didn't even thought that I will take that long flight. And Chile is a very large and long country, actually. So we don't think about that, but it's, I think, 4,000 kilometers from south to north. Also, today I will be talking about ESO, which is European Southern Observatory. And I think we will go to map later, but I think with that, I will immediately give the floor to them. So they will introduce themselves, and I will help them with other things. But let's start with the introduction. What is ESO?
We are ESO, the European Southern Observatory, and for decades we've been designing, building, and operating the most advanced ground-based telescopes in the world.
We're developing very, very challenging projects that no one else in humankind has ever done. There are people who build a bridge, they go to the seaside or to the mountain. We are building the highway towards knowledge.
I think what's special about ESO is the level of international cooperation that's really enabled astronomers to study all sorts of different phenomena in the universe.
Here, astronomers took the first direct image of a planet outside of our solar system. Here, they established that the universe is expanding ever faster. Here, they found that there's a supermassive black hole lurking at the center of our galaxy. And thanks to a worldwide collaboration, we know what it looks like.
And now we're getting our first image
of a supermassive black hole
in our galaxy, the Milky Way.
Here is in Chile. ESO operates its three observing sites in the Atacama Desert and is proud to have access to one of the world's best locations for astronomy.
I never thought I will be part of the discovering of the universe. It sounds big because it is, you know, it's crazy.
Yeah, I've been tens of times in Paranal. I enjoy every single sunset.
We're a partner in ALMA, the most sensitive array telescope in the world.
I never encountered such a nice, warm set of people as are at the site here at Alma. And I just love the action that takes place in daily operations here.
Being in places like Alma or Paranal or La Silla, I haven't met anyone that has visited and then just went on with their lives. You're gonna get some new perspectives.
You are the author of almost 2 years, which I spent in Chile. I never regretted a silly moment.
So I was at Paranal Observatory. If you remember, there were a few sites. We will go into that in details. And it was part of the job application. So I applied this year for a job at ESO in Chile, and I was officially invited, this is the letter that they gave me, to visit the observatory, Paranal Observatory, as part of the job selection process, as a last step in the job selection process. Now, to make the long story short, I got a job there, I've been offered a job there, but after 2 months of thinking, it was a super difficult decision, but after 2 months thinking, we decided as a family not to go to Chile because it's a little bit difficult for the family. But I got an opportunity to visit it, so which I am very, very glad that ESO gave me this opportunity. So in the beginning, everybody was excited that, okay, we will go to work in Chile, and it was super nice, but over the time, it was kind of not as bright as it was in the beginning. I've spent there 3 days, and the schedule was super intensive. So you see here, that is the real schedule that I had. And it was part of the kind of competition they put so for the people who wants to work there. So I have to meet some people, I have to, let's say, to present topics and discuss different things, and at the end make the final presentation. So that was the very intense time there. When I was going there, I hoped that I will have more free time, but it was not the case. But I was very glad to be there, meet a lot of people. Also, I have a pleasure on the way to Paranal, stay for a short term in the guest house in Santiago. I was also meeting some people from the organization, and everybody was super welcome, super nice, and I had a feeling that they treated me as a king at Paranal, so it was very, very nice. But not enough free time. What I was thinking to do today is, first part, talk about ESO and why this site, why Chile, how it happened, what they do there. Just give an overview of the, let's say, scientific part of the story. It will take long, so just don't be worried if it's too long, just stop me. We will go in very detailed. You will maybe know way more than regular ESO in play will know, but okay. And finally, after that, I will share my impressions, how it was for me there. And essentially, the organization is very live. So they have, where you see they have instruments already operating, observatories, but they're building new observatories as well. Okay, so it took super long time, as you all know, to have a good equipment, to make a good photos. It takes a lot of time, a lot of effort to build this. And this is the quote that I have here: astronomy is a school of patience. That is true also for ESO. So it all started 60 years ago, even more, when there was an idea of the European astronomers to build an observatory or station in the South Hemisphere. Why they selected South is that there are a few reasons for that, because as you know, the galaxy center, the Milky Way galaxy, is visible there way better than here in the North Hemisphere. Also, there are a lot of unexplored places on the sky that time, which was very interesting to explore. And in 19th century, so way like, I would say, more than 100 years before this historical event, astronomers started exploring the South. So the first base was the South Africa. This is the place where in 19th century the first people came and started building the observatories. Herschel was one of those people who built a private observatory there and observed the southern skies. And then some European universities also after that followed this approach. Back in the time, Leiden University in the Netherlands, they had the station there, and they also played a large role in this setup of the place. Now, the funny thing is that they were looking for South. They selected South Africa, but they end up in Chile. That's interesting. Of course, they spend some time like this to explore the place, to find, okay, what is the good place or not good place. This is just first equipments that they brought just to select the site, which is very important, as you know. And actually, they spent like 8 years looking into the places in South Africa. Probably the weather was not as nice, maybe something else, but it took so long. And it was challenging, as you can see here. And they were testing and testing the different sites. However, in the South America, some people were exploring Chile. Americans were exploring Chile for potential southern station, since somebody suggested that Chile might be a good place. So when a representative from an organization went there, they said, okay, Chile seems to be a way better place than South Africa to establish this. So that's why it's Chile. So that's why after 8 years or 9 years, it was decided that the Chile will be the place. And it has a quite unique climate and quite unique conditions there. First of all, it's very, very dry. What you see here, for example, is the ocean, so the Pacific Ocean and the mountains, the land. So here, in the very, very center of the slide, there is Antofagasta. So Antofagasta is the closest city to the Paranal Observatory. It's very dry. Typically, within 1 year, it can be one-shot rain. Just a few millimeters of rain, even sometimes not even exist, within 1 year. So, amazingly dry place, so no humidity. And also, it's very steep. So if you think about, we cannot see it here, but, and we are from the very high distance, as you can imagine, we're looking from the space. So just to give the perspective, from this place to somewhere here, it's around 1,000 kilometers just on the. So you see that Chile is going all the way from the bottom of this picture all the way to the top. It's 4,000 kilometers. Now, Antofagasta is a very dry place, and it's also, as you can see here in this side, 95% of the skies are clear, 95% of the nights. Also, what makes us very specific is that we have ocean here, and then the mountains are going very, very steep and high very fast. So, Paranal Observatory, I think, is located within maybe, I don't remember exact number, but approximately within 15 or 10 kilometers from the ocean. So it's very, very close. I don't remember the exact number, but it's less than 20 kilometers, or approximately 20 kilometers, maybe less, just from the ocean. However, they are very high. So that means that from zero elevation, we go to 2,000, 3,000 meters, super steep, super steep. So, in fact, when you see in the picture, Paranal will be very, very close to the ocean. So, if I point my pointer here, it will be somewhere here. So, just from this perspective, it will be just almost to the ocean from this distance of view. Now, what makes this a little bit special also is that because it's very dry, no rain, only a few millimeters per year. We have even less maybe. We have a lot of dust. So, but it doesn't reach the observatory as that much. But near the ocean, it's a lot of dust. Chile is very well known for the mines. So for the copper mines. So all this region is the copper mines, what you can see on the screen. I was in the Paranal, which is the somewhere here, close to Antofagasta. ESO has also La Silla Observatory, what you saw before on the video, and it's located somewhere here. So more to the south, within probably, I think, at least few hundred kilometers apart, probably up to 1,000. And it was the very first original site of ESO. Then they decided to go to Paranal. So, very special place. 5 countries signed the convention to select Chile and to build the ESO, European Southern Observatory, and it was more than 60 years ago. So the first countries were Belgium, France, Germany, Netherlands, and Sweden. So there was the very first countries which established this, because in that time, for one country it was not possible to support to fund this. This is where La Silla starts. As I showed, this is when you look on the map, this is more to the south. They started with 1 meter telescope, and now ESO has 16 member states. So many countries joined later, like every few years one country joins. So this is a really European observatory now. Chile as the host state and Australia as a strategic partner. So that is the current situation as of now with the ESO. Approximately more than 700 people work there now, and there are many more different nationalities, as you can see here. Just so very diverse stuff. And sorry, and also it's very well known to produce. It's like a astronomy data factory, I would say. If you would say in one word, it's astronomy data factory. So they produce so much data, then a lot of publications are based on that. So as you can see here, it's only increasing. And this is enormous amount of scientific data and publications that they have here. Let's go deep, and this is the longest and deepest part now, into the specific sites and specific instruments and what they have there. I was in Paranal, which is on the left here, and in Paranal they have a few telescopes. So the first here you see that VLT is a very large telescope. It's effectively four telescopes, four close together, and a few accelerated additional telescopes. Vista is the survey telescope, wide field survey telescope, and CTA South, so the Cherenkov telescope array. We will discuss it later. This is the future. So this slide shows the existing ones and the future ones. Then you have ALMA. ALMA is a special, let's say, telescopes. They are not optical. This is for the millimeter and submillimeter radio waves. And this is also located in Atacama Desert, but it's quite far from Paranal, and it's a very special place. We'll discuss it later. Historical site La Silla. This is where it all started 60 years ago. And finally, the largest ever telescopes to be built is Amazonas, very close to Paranal. This is what they have at the moment. And you see that La Silla La Silla is like a telescope village, many telescopes from different universities, from different places. Paranal is the most advanced at the moment. The ELT will be the largest one, and the Chakhnata Plateau is for ALMA. ISO is the partner in ALMA. ALMA is a consortium from a few partners, different universities. From the elevation perspective, we have La Silla and Paranal, which is very similar elevation. It is between 2,000 and 3,000 meters. The new ALT will be 3,000, as you can see here. And ALMA, for the millimeter and submillimeter, will be, and it's located at 5,000. So very high in this case. If you look on what they do, well, most of the infrared and visible, you can see here that this is the most part of the telescopes for the Paranal, for the Very Large Telescope, for Vista Survey, for La Silla, and ELT will be in the same range, visible and infrared. ALMA is, as I mentioned, it's a millimeter and submillimeter waves, so it's microwaves. And Cherenkov telescope array, when it will be in place, it will be capturing the gamma rays, but I have a slide on that later. So La Silla, very quickly, this is the equipment they have. I haven't been to La Silla, but this is just for information. Still operating. It's a village, as I said. So many different telescopes, very small ones. 6 years ago now, they have outreach event, very interesting outreach event, when they invited people, let's say educators, scientists, astronomers, also public people, to observe the solar eclipse there. Because that is one of the few occasions in the history when the solar eclipse, the totality of the eclipse was exactly here, was visible here. Of course, not only here, but in Chile, and also in, I think, in other countries. But it was, I think, so in the history that was first event in France, a long time ago, I don't remember which observatory, there was a totality of solar eclipse. Then it was Hawaii, and then third time, 6 years ago, the totality was here. This is the events when the totality was passing through the large observatory. So they used the opportunity to use the outreach. So there were a lot of people visiting, making photos, promoting this event, and also some scientific results. For example, they checked the positions of the stars around the sun on the totality, and to confirm the general relativity theory. La Silla brought some important discoveries. They got Nobel Prize in Physics for discovering that the expansion of the universe is actually accelerating. that was based on LaCie data. They found the planet around Proxima Centauri. They checked the anatomy of the one asteroid. And now let's go to Paranal. As I mentioned, Paranal is the new observatory, well, new compared to LaCie. I think the first light here was 20, maybe a little bit less than 25 years ago, between 20 and 25 years ago, 23 maybe, and around 2000. And Paranal consists of the 4 telescopes. Each of those are 8-meter diameter of the mirror, and they can operate independently or together. So it means that they can make a large interferometer, optical interferometer. For that, this is like a flat, you see, they call it platform. And this platform, under the platform, there's a, let's say, there's equipment and the lasers, not the lasers, but the beams, the path for the beams for the light to correlate. And the laser is used for the artificial star. I will explain that later. Each of the telescope has its own name, but actually they all known as UT, UT1, UT2. So in reality, no one used these specific names. This is from the indigenous people there, so they named that to respect the local culture. And as I said, they have 4 telescopes, exactly identical. This is the platform, as they call it. And then you see that they have also 4 additional small telescopes, well, comparable small, each of them of 2-meter telescope. So it's not that small. And if you notice that platform has specific positions here, and there is a light path. So this can open, and the light and the instruments can be connected to this. So they move and they can sit on the specific positions in the different configurations. That means that all 4 small ones, they can move around. Now, sorry, there is a quite large building here, and it's quite special building because there is a lot of people working there and a lot of space. So, and typically during the day, it's very quiet, but up to the evening, a lot of people in the control room. So there's a large area here, which is a control room, and then you will have maybe 20 people at the same time. Each telescope has its own control station, a lot of monitors. So it's really quite different and probably quite unique, because typically, yeah, you don't have that a massive amount of people in the one room with telescope operators, with supporting astronomers, all preparing for the observations and also monitoring how the observation going. On the neighbor mount, there's a Vista. So Vista is the survey telescope for optical and infrared, if I remember correctly. And there are two local, traditions associated with this. At least 2 I know. First of all, every evening, because almost every evening is clear, right? So they observe all the time. So actually, there is a ceremony for each of the UTs or telescopes opening. So there is a special procedure. Telescope is in the beginning. They rotate the telescope 360 degrees, so to check it how it rotates, if everything is okay. And this happens just before the sunset. Then they incline the telescope so the mirror will be against the sun. And then finally the domes are opening. So these parts here, they're huge and they are opening like this, so on sides. And then you have this procedure. So this shields here, the small ones that you can see, is a protection from the wind. And it's very impressive because this age of telescopes, they are so large, and yeah, it's like a special thing. Also, every evening, some people go there to observe the sunset, because as you can see here, this is location to the west. So we have mountains, we have clouds, but on a very clear day, if that happens, I haven't seen that, but after the clouds, you can see the ocean. And you can see that ocean is super close. So it's actually, when you're so high, you can easily see ocean, because literally it's maybe 10, 15 kilometers from the ocean, but still very high. And the sunsets are very impressive. So if you remember the video, some people say, oh yeah, I enjoyed the sunset from this elevation, because indeed sun sets in the clouds. And it's very good to, and it's super nice to view here. Okay, very special place is where they live. You can see that they are on the top. This is all 4 UTs, 4 telescopes. And this is underground, because this part looks like it's a building, but on the other part, you will not even see that it does exist, or you'll see the photos later. Interesting enough is that it can accommodate up to 150 people, so they have canteen there. Each astronomer or each support staff can have his or her own room. They can sleep there, but all the rooms, they look identical. And these here sittings are just on the canteen, so you can have a meal there and look. Inside the building, so it's a very long building. Inside the building, they have compartments also very far away from the entrance, where the night people sleep. So the people who observe at night, they sleep far away from the entrance, so they will not be disturbed at night. Also, which makes this place very special is that all water that all these people use arrives there by trucks. Yes, so there's no water there, no water source, and you can see here that, yeah, it's very, very challenging, and it's far away. So just for perspective, the nearest town is with approximately 120 kilometers. The largest town, I think, in the area, Antofagasta, and every day, a couple of trucks, more or less, maybe not every day, but a few times a week at least, a few trucks just transport the water from Antofagasta to here. And I think it takes at least 3 hours for the truck with water, maybe longer, to bring the water to this facility. What is even more interesting, they have a swimming pool there. Yeah, and this is how it is inside. But the swimming pool serves the interesting purpose because it's very dry outside. So having swimming pool inside gives humidity to the air inside. So it's not that dry inside. So when you enter, you don't feel very dry, you feel humidity. Because there's evaporation, obviously. So they lose water also there. Also, that's interesting. The roof of this house, they call it residencia, which is Spanish word. The roof of this house is open during the day, but you see that they shield it during the night. So there's no light can escape and intervene with the light pollution. So this construction here automatically opens in the evening, and it's like very thick, so it closes because the light is on. So it closes all the light that comes in. But during the day, it's open, so the sun can shine because this is made of glass. Huh? Okay. So technically, VLT, as I said, it's 4 telescopes. When they combine, it's the equivalent of 60-meter telescopes, which is logical optical one, and it can act as an interferometer. So you can see approximately the situation, how it looks like. Each of the four is 8 meters. And they use many instruments, of course, but from the technology point of view, they use active optics, adaptive optics, and interferometer. So a little bit on that. So active optics is quite old concept. And the idea here is that the mirror is very large, it's 8 meters. And then when you move the mirror, because you cannot make it very thick, even if it will be thick, it will deformate from its weight. So the idea here is that the active optics will support the mirror, so the shape will be as perfect as possible. And first it was tested in La Silla, this concept, before implementing here. So you can see here in late 1980s it was tested and designed. Now it's widely used everywhere, and you know that support cell even, yeah, it's a very common concept. It's all about the shape of the mirror, right? So they compensated the gravity, the changes of the shape, and it's controlled by the computer. So they check how the wavefront is changing, so they can have a closed loop control to adapt to this. Now, adaptive optics. Adaptive optics is a new concept, and this is just to improve the seeing. So you know that, of course, I assume it's a very good seeing there, but still, adaptive optics can improve it better. And for that, they have very powerful lasers there. It's quite dangerous also. So there's a special safety procedure for the staff to operate, and also to prevent any issues with that. What happens is that the lasers, they light up the artificial star at the elevation of 13 kilometers. So they, let's say, they accelerate or influence some molecules there that can create an artificial star. And as for lasers, so they install it on the unit telescope 4, so the last one on the right. And the cabinets are very high, very large actually, and they have these beams of the 30 centimeters diameter. So the beam of the laser is quite thick actually. So and there's also the interferometer. You can see that if they, yeah, sure. That's a very good question. I think, no, I don't know. To be honest, I might guess that it can be to, probably, I might guess that it can be the technique to control, or let's say if you want to use adaptive optics, you need to know what will be the changes of your target, and that's 4 can cover all 4 corners around your target. That is my impression, because if you project it to the sky, then I assume that around the target you will have 4 artificial stars there. That will be my kind of guess, but I don't know exactly. Yeah, good question. Thank you. And interferometer, I told about that. So underground there is a light paths. So you can see here that there's a lot of happening on the ground of this platform. And you don't notice, but there are a lot of space underground as well. So here is an example of the interferometer inside. can quickly check what they discovered. So they got a Nobel Prize in 2024 for the discovery of the black hole in the center of our galaxy. Actually, they checked the stars close to the center of the galaxy and they see the movement of that. They capture the light from the merge of the neighbor stars. They see it in the, they capture the event of the gravitational wave in the visible light. They image the first exoplanet. And now let's go to the last point here. What they do have is the ALMA. ALMA is the consortium, so it's not exactly ESO, but it's a consortium of the few institutions. ESO is included. And here is, this is interferometer, and it's very high, and they can move all these antennas around. So you can see here that there are small antennas they can move around, there are big antennas, so they can, what is used for is to study the cold gas, for example. These are the partners who made it, and for example, they use it to study gas, molecular gas, or dust, and this is the scientific focus on these topics. You can see here that they study the molecules from the star-forming regions and also from the comets. There are 66 antennas, they all can be moved, and all the equipment is located on 5,000, but the people, they will operate on the base, which is 2,000 meters lower in the 3,000, but the site consists of two parts. And this is not, let's say, this is also Atacama Desert, because Atacama Desert is huge, but they are quite far from Paranal, so it's not very close. This is what they did. So they captured the dark hole in the M87, the planet formation disk, so the protoplanetary disk, they can do this, and they did it. And also, as I said, detecting molecules in space. Okay, with that, we covered the, let's say, the existing instruments. Now I will explain what they were building, because I said ESO is developing. So this is what already they have, and they were building a few other places of the observation. So let's try to start this.
ESO, we build bridges between countries. Chile, our member states, and strategic partners, and our many collaborators in industry and academia. And we build bridges between science and society. We educate and inspire. We generate business opportunities, stimulate development, and train the next generation of astronomers and engineers. Our headquarters are in Germany. This is our administrative and engineering hub, where much of the telescope design and development takes place. Our engineers, together with many partners and experts from industry and academia, have been advancing technology for over 60 years. Since building our first telescopes, we've increased the mirror size from 1 meter to 3 meters, to the 4 8-meter telescopes of our flagship, the Very Large Telescope. We've built deformable mirrors. We have lasers. Now we're building a telescope that will bring about a new era for astronomy. the Extremely Large Telescope, a giant with a main mirror of nearly 40 meters. Okay, the name might not be very inventive, but to build the ELT, you need to be.
It's an enormous project. It's a monster. I mean, it's, deep down that you will never get to see another project like this in your lifetime. We only build prototypes. So we're breaking new territory every single day here. And this is amazing for a scientist, for an engineer, for an administrator that supports this.
To me, it's about being in this constant state of reminding myself that there is still a lot to learn, and that there is no better place to be learning new things as it is here. This is exciting. This is a big motivator.
We're solving puzzles, such as how can we move thousands of tons with precision finer than the thickness of a human hair? How can you make 800 separate mirrors behave as if they were one? And how can you build all this to withstand a strong earthquake? Together, we push the limits of what is technologically possible.
We're doing this for a purpose, because it's the very most powerful scientific tool in ground-based astronomy for the next 2 decades. It will poke into corners that we can't even anticipate today.
We are certain to find things that we haven't thought of before. It's been true of every telescope that's ever been commissioned. So I'm really looking forward to being surprised.
For my daughters, my grandson, and for many little people today, they will know more thanks to these machines.
So, do we have all the answers?
No, definitely not. But that's part of the excitement. I'm an astronomer here at ESO, and for me, the excitement is about figuring out if there could be planets out there that have an atmosphere similar to the one we breathe here on the Earth. And of course, finding the answer to the ultimate question. Are we alone, or could there be life out there in the universe?
One thing is for certain, staying curious and searching for answers as we do here at ESO never gets boring. Join us on this journey.
Okay, let's join them today at least to see what is future is coming there. As I mentioned, let's talk about this. It's not yet built, but it's already impressive because personally I cannot imagine how large it is, because first of all, I have never been very close to it. I only saw it from the very high distance, but even from the high distance, it's very large. And also, I think at the moment, and maybe forever, I don't know how the future will bring it, but maybe that will be the ever largest telescope built on Earth, because maybe technologically it won't be possible to build something larger. So maybe that's the limit. No, they even pushed the limit here. Just for comparison, this is the mirror, and it will consist of almost 800 individual pieces. What is makes us very interesting also is that all these segments, they will be, each segment every 2 years will be recoated, and let's say the new silver will be put on that. So the reflection surface will be put on every 2 years on each segment. That actually means that every day a new segment will arrive to the laboratory, and then it's constant, so it's absolutely constant change of the segments. So that effectively means every day they have to prepare one segment of the mirror. And you think it's like every single piece is, I think it's approximately 1.5 meters, if I remember correctly. So it's a quite large piece of glass. So it's kind of, and it's a mirror. So this is what will happen. It's not very far from Paranal, but still far. So you can see here on the picture on the left, we have Paranal Observatory, which we've just discussed. And then 23 kilometers away, they're building ELT. So not very far, but a new place, and it will be on the 3000. This is old picture. So at the moment, they have already the dome ready, and they put the, how to say, the shield. So the skeleton is ready. They are putting the shield. The mirror is segmented, but as in many instruments, this type, they will have also additional mirrors, secondary mirror, third mirror, etc., etc. So you can see here, and as of we speak, the mirror number 5, M5, is being prepared. For the comparison, if you remember, we talked about Paranal, and it's here, and ELT is here. That is the way Everlarge is there. Now, there are two other projects which you've heard probably about it. So first of all, this is the Giant Magellan Telescope, also in Chile, in Las Campanas, but they're still under construction, and it's not ready, right? And the size is small, also very, very impressive, but the size is small. And the Paranal site is not far from La Silla, so it's way to the to the south. The 30-meter telescope, you know that originally it was planned to build in Hawaii, but for the last 10 years there were some discussions with the local people there and with some other institutions. So it's actually not progressing at the moment. There is no confirmed site for this telescope. As a backup plan, La Palma in Canary Islands was considered for that, but it's still like unconfirmed. So, which brings the ELT is the largest one, and it's currently under very intensive construction. If you compare that, the Paranal here, the Very Large Telescope, looks tiny and very small compared to ELT, since it's a few times larger at least. Okay, so why LT? I think you've heard that in the video, is that it's all about exoplanets, Earth-like planets around other stars, and just to study that subject, which is very important. That's also one of the topics about dark matter and dark energy that they will try to tackle with this instrument. Other studies about evolution of the universe and galaxies. Finally, there is another telescope instrument, is in planning phase and in building phase, which is the Cherenkov Telescope Array. And this is a special instrument. They will capture and study the gamma rays. But how? As you know, the gamma rays, they can be very, very high in intensity particles, so unbelievable intensive. When they reach atmosphere, they create a cascade of the electrons, and it can be detectable very fast with the visible light, actually. So these instruments will work to react fast and to detect this in the atmosphere. So they will be looking into the light which has been created by the gamma ray, very high energetic particles. And those particles is the most energetic, let's say, photons or particles that we have in the universe. And as you can see here, they create this very fast, moving phenomena. So the phenomena is lasts for very short time, and hence it's very special instruments to detect. So they should capture very fast imaging. And so they will have, yeah?
One question is this is about gamma ray bursts.
Yes.
But they are really very short. No?
Yes, but I think there are I don't remember exactly, but the cascade which is created, it lasts for enough time to try to capture it with these telescopes. So they constantly monitor the atmosphere, so they can detect these fast flashes of this. Because when the cascade of particles creates an atmosphere, it's visible in a very short time, and that can be detected.
Minutes then, or seconds, or?
No, the duration is like milliseconds.
The GRV of the gamma ray burst itself.
I don't know. That's a good question.
That's milliseconds, but then these instruments, if they have to respond to that, they do that in milliseconds, right? You have to seconds.
Yeah, that's a good point. Indeed, my understanding is that if the event happens, they will get an alarm and they rotate the telescope as fast as possible to capture it. Maybe the duration, I don't know, maybe minutes indeed, or maybe shorter. I don't know what is the duration of this event. But the flash itself is very short. I know this is very short. There are two parts. So in Chile, they would like to make a southern part of these telescopes. In La Palma, they have a few telescopes, so it will be way more. In Canary Islands, on the north part, so they will have two parts, north part, and so that's why it's a Cherenkov telescope array south. A very special kind of, you see that's a very special technique, so it's an open mirror, no closure, no enclosure. This very same technique is used in La Palma. Actually, I think in La Palma, they first tested it and tried it out to confirm. And now I know that they're building La Palma, they're building this, in the Northern Hemisphere, they're building these ones. It will be allocated in the same area. I think this is the image from, probably an artificial image from the Google Earth or something like that, I'm not sure. But you can see here both observatories. So here's Paranal, and here is the ELT, the future site of ELT. Okay. Well, finally, they capture a lot of data. And their data center, I would say, is also quite impressive. So technically, it's a very large room with a lot of equipment. And this data, they accumulate there, and it's available for researchers, for public, and they have a lot of, let's say, discoveries made of that. So that is, let's say, a result of this. So as I mentioned before, for me, it looked like a data factory, in fact. So so many observations, so many data captured on every single night. I think with that I would close the first part of the story, which was mainly theoretical, what the science they do, what the sites, what the consistence. I was in Paranal, so then I will tell a little bit of my photos, and so in the second part I will briefly explain what I saw, how I feel it, etc. But maybe before my one, sorry. Any questions? So where's my mouse? Here. So how was my trip? So here you can see that, again, same map, Credit Suisse. I came to Santiago, which is a main city in Chile. So Santiago has around 8 million people. So it's way larger than Brussels, for example, for comparison. It's huge. And it's very large indeed. And then I took a flight, so I was like happy to stay in the guest house. So ISA has a guest house in Santiago. So it's like their own hotel, a small hotel, which is in the past was their office, their small office, and they converted this office to the hotel. So now, if people come to Chile, like for example astronomers, they come to Chile, or engineers from Germany, they come to Chile, they stay in the guest house and not in the hotel. So that is the concept. It's small, it's nice, but it's not a hotel. But it's very nice there because when you stay there, you talk to other astronomers and you have a very nice conversations there. So it was amazing time. So again, thanks to ISA for the opportunity. The guest house is quite small, maybe 10, 12 rooms, but still it's very cozy there. On the way to Paranal, quite far, huh? So I took a flight from Santiago to Antofagasta because Antofagasta is the closest town. The flight was almost 2 hours, so you can imagine the distance. It's like from here flying almost to Madrid, a little bit closer. Barcelona is maybe. So just for example, from here from Brussels to Barcelona, that is comparable flight. That is the comparable distance. Probably a little bit more further. I didn't check exactly, but almost 2 hours, 1.5 more or less. And then from there, ISO has a bus which takes the people from Antofagasta airport, and that brings them to Paranal. So a result of that, the trip is long. I left the Santiago place around 6 o'clock in the morning, even before that, 5:45, and I reached Paranal only around, I would say, 1:30, 2 o'clock in the afternoon. So you can imagine that from 6 in the morning to 2 in the afternoon, it's 8 hours. So 8 hours of travel. This is the time which takes you to get from Santiago to Paranal. Just for information, La Serena is the closest town for La Silla Observatory. I haven't been there, but so people who go to La Silla, they fly from Santiago to La Serena, 1 hour flight, and then again time to reach La Silla. The distance from Antofagasta to Paranal here, approximately 2.5 hours by bus. So that is approximate distance. And then I haven't been to the Alma site, so this is the plateau of Chajnanta, but that's probably even longer to get there. So this is perspective. In Paranal, this is Santiago, by the way. So I was there in June. It's the middle of the winter, and you can clearly see a lot of snow. The temperature at night was quite cold, I would say around maybe, on some clear nights it was around maybe 2 degrees, maybe 3 degrees Celsius. But when sun is shining during the day, it can be easily like 18. So the changes are quite different. Santiago is located very close to the mountains, as you can see here. On one side, but another side, it's around approximately 2 hours by bus from the ocean. What makes the ocean special there is that it's very cold. Actually, that drives the climate also. The ocean is very cold. This is the current, global current, that also contributes, I think, to this very special conditions for astronomy. Now, that was Santiago very briefly. When I was on the plane, of that almost 2 hours plane to Antofagasta from Santiago, I can see the observatory from the window. That is my photo taken from the airplane. just sitting looking into the window. And just for perspective, so here is Paranal, and just take this photo. So here is Paranal, you can recognize the platform. And here, so you can see this small building here. This is the residencia, so the hotel in Paranal. And here are some additional buildings. This is the place where they will be also changing the coating of the mirrors that they have for ELT. You can see also a huge, let's say, plant of the photovoltaic plant of the solar panels. So this is it's not ISO plant, it's an electrical company, energy company that is owning this plant. As you can imagine, from the airplane, this is huge. But also what is very surprising is that you can easily see all the 4 telescopes when you see them from the airplane. And you can also see Vista here and some other telescopes. Yeah, that is impressive. That is so large that you can even see it from the airplane. On the same view, the same photo, but you can see the ELT. So this here, maybe it's small, but this is the extreme large telescope, the one that is built with a mirror of 39 meters. Another impression, so you see that ELT here on the top of the mountain of the 3,000 meters, and then there are obviously way higher mountains there. So here's how the Paranal looks like for me. I stayed in this building, which is, you saw, that's residential. So from this part you see that it's underground. This is the dome that I told you about, which they shield from the light. And this building I spent quite some time in. This is their offices. So it looks like construction offices, like, you know, when they have a construction site, or when you're on the oil and gas field, you have the very same concept. They have same concept here. This is the place where they work. And from here, you see a lot of cars. To reach the platform is about 5-10 minutes by car. So basically what people do is that they drive there by car and they drive back when required. What we don't see on the right here is additional buildings for the coating, for the also for the safety and all these topics. Now, it's a little bit special place because you see that it looks like a Mars. And in fact, NASA was testing rovers here, because rovers that are going to Mars, to explore the Mars of NASA, they have to be autonomous. So they have to, the signal goes 40 minutes from Mars to Earth. So for 40 minutes or even longer, they need to be self-sufficient to drive and explore the Mars. That was the perfect terrain to test it, and they did it. So that is one of the topics that they have here. Also, at night, in every room, you will see it later, in every room there is a, let's say, the plate saying that you need to close the curtains because they don't want to light pollution. So if people start to switch on the light in their room and the curtains are open, of course that will affect the observations. So that is also makes place specific. To be honest, it's very remote, so you don't have a lot of entertainment there, right? So you cannot just go for a walk. The only possible walk, because I like walking, I like hiking. So from here, from platform to here, there is a, they call it Star Trek, or Star Trek, something like that. It's like a path, which is quite good path, which you could hike. So maybe you can barely see it. Here it's starting to extend there. Takes approximately 40-45 minutes. So I did it a few times. It was great fun. it was like, yeah, some exercise to do. But that's the only probably hiking place here. And otherwise it's quite dangerous, because if you got lost, then all this hills like look very similar, so it's not allowed just to go for a walk to the hills, huh? So you can easily get lost. As I mentioned, this is a typical view from just a window. You see, like nothing, no trees, no grass, and this is what it's inside. So they ask to close the curtains in the evening if you turn on the light. And that is interesting place. So this box here, or this small town, is actually, they call it UT5. And this is the place for amateur astronomers. So it's very interesting because it has a telescope with a mount. So, and they have a group of people who are allowed to operate it. So, for example, if somebody is interested in this, you need to subscribe to the mail list, and actually in the evening somebody will come and try to show you this this instrument, and also to show you some objects. For me, that happened. It happened not as I would expect, but it happened, because what I was expecting this in the evening, I would go there, somebody will teach me how to use the telescope, and then at the morning or at night, I will go there on my own. But effectively, they have like a few levels of that. So the person who were there, she was very kind, but she was not authorized to teach someone to pass the, let's say, the rights. So there's only probably 2 people who can pass the rights to other people. That's the thing. So as a result, we were just observing a little bit together in this place. The conditions were not extremely perfect, because by that time it was, let's say, half moon. So I think 7 or 8 days moon. So there was light pollution, of course. But we observed some objects, and I think the most recognizable, remember, was Eta Carinea, which is not probably visible here, but it's a very nice nebula, very bright nebula. But they call it funny UT5 because this is official UTs, and this is a small telescope, which is, let's say, maybe the very kind of unique place where they have something for amateurs. So because there's some staff working there, they also amateur astronomers, hobby astronomers. This place in the evening and during the day, all these hills, they change the color a little bit, so it makes it very special. This is the view in the evening also from the top. And also in the evening, as I mentioned, there is a ceremony, so some people watch the sunset and some people go to watch the opening. As you can see here, we're looking now to the ocean. The ocean is not visible because there's a thick layer of clouds there, but it's very close actually. So we're at 2,600 at the moment. Of course, we're very high, but from this distance, if it will be no clouds, we can see the ocean. Sunset, again, clouds of ocean of clouds, but hiding the real ocean. And you can see here literally, again, it's approximately maybe 10, 15 kilometers, maybe even less, from the observatory to the sea, to the ocean, to the seaside, which makes us very unique because that is the only probably place so close. Maybe Hawaii also. Oh yeah, La Palma, but yeah. This is inside, so these are the lasers that I talked about. This is the moon, which I mentioned, which was not perfect for that observation. Now I have a couple of videos. Let's try to play them because they show the. Let me check if I still have the internet. They show the opening. and the telescope's movement. Yeah, you see, so they rotate the telescope here. The quality maybe not the best one. This needs to be buffered. So they are making the regular procedure to prepare the telescope for the observation. So they check how it's rotated, if everything okay, they rotate it 360 degrees as I mentioned, and they do other checks. Before doing that, there was also procedure to check that there should be no one inside the dome because it's moving. Another video is of the opening. Let's have a look. And I hope it will load. So opening, a very special moment. Very unique moment because it's dark inside, but when they open, it's still before the sunset, so the sun is shining, and then all of a sudden you have a lot of light. So that is the moment. And this happens for all four of them, so this is just a one. Okay, good. This just made with maybe 10 seconds exposure. I was impressive. And this is very early in the morning. Because of the time difference, it was very easy to wake up around 5 o'clock. Because if I remember correctly, 5 o'clock, it's I think around 11 or 10 o'clock here. So 5 o'clock in the morning, it's 10 o'clock in the morning here. So it's not very difficult to wake up, which I did. And here we have maybe half an hour, maybe 1 hour before the sunrise. I don't remember exactly. And what you see here is this, they already move away the shield, because that should not be like that. During the night, it's absolutely dark. And now it's already like, I would say, not a sunrise, but not far from it. Maybe it's nautical night. Astronomical night is finished, definitely. Otherwise, they will keep it closed. And probably that's the thing. And then it's just a typical, I think from the sky perspective, it just, again, is a few seconds exposition. No tracker, just very basic one. And to be honest, the sky was way more impressive than in Canary Islands. So, because it was just dark. The Canary Islands is not that dark, I must admit, compared to this sky. So it was dark. I never saw that. That's the first time ever I saw them too. Never some. You see here UT5 also. Some lights on the road. But yeah, Magellanic Clouds, very impressive. Another photo of just Milky Way. This is the trees, the only trees they have in the area, which is very close to residency. By the way, at this moment it's still dark, so it's already closed. It's yet closed. And this is the only place where they plant a few trees here near the hotel. And in the evening, this is if you remember, I mentioned there was a moon. And in the evening, when you walk, you can see the laser, actually, like this from the telescope. Another photo. I think that's it. I don't have any more photos. Yeah, well, I have a few, but I think they are repeating each other. So thank you very much.